Hello everyone and welcome to another Fusion 360 Tech Thursday. My name is Brad Tallis from Autodesk, and today's topic we're going to be talking about bringing in parts from McMaster-Carr and using them in a Fusion 360 assembly. So you can see on the screen here, this is basically what we're going to be creating today. So I have this little sub-assembly. It's got a bunch of bearings, some bolts, some nylock nuts, etc., and then this little stepper motor, this NEMA 17 stepper motor. So this is what I'm going to be showing today. So let's go ahead and dive right in. Now I'm going to start with something just a little bit different. I've actually experienced this personally, and I've seen some comments about this, but I have this part that's kind of floating out in space, and I want to position it down onto this other part. And so I'm going to go ahead and use the Assemble menu, and let's create a joint. So I'm just going to zoom up and click on this edge here and this circular edge right here. Now I want to be really careful. You'll notice when I'm hovering over this edge, it's selecting the whole edge, but sometimes you'll get where there's like an end point, and I do not want it to catch right there. I want it to catch in the center. So you'll notice that I've zoomed up on this area, and so when you're positioning parts, I highly recommend that you zoom up so you can kind of see what's going on. So I'm going to go ahead and click that edge, and it's going to bring that part and line up those holes. And you'll notice that it's using a rigid motion type. Okay, so it lined those up, but now I want to go ahead and line up, this hole with this hole over here. So I'm going to go ahead and say okay. We'll use the joint command again. And this time I'm going to say this edge, again making sure I grab the correct edge right there. And then I'll go ahead and select this edge here. Now you'll notice I get a warning that says a joint already exists between the selected components. Do you want to continue? And this is what I really wanted to point out, because a lot of people think, oh, you can only have one joint, and that's not true. You can actually have more than one. So yes, I want to continue. However, you'll see that it goes ahead and lines up that joint, but I get a warning that says the selected joint type would result in a conflict. I'm going to go ahead and say okay. And sure enough, you can see down in my timeline, here's my first joint that I created, the rigid joint, and then here's the second rigid joint, and it's highlighted yellow saying that it can't do that. So how do we go about positioning this correctly? Well, the issue is the fact that I'm using rigid joints, and if you kind of look at this, if this is lined up right here, we basically want to rotate this part around to line up these other holes. So let's go back and edit this joint type, and instead of making it rigid, let's change it to revolute, and you'll see that it's going to revolve around that particular axis, and I'll say okay. Now it's still complaining at me, but it's now able to rotate around this hole. Well, let's do the exact same thing over here. We want it to be able to rotate around that hole. So I'm going to come in here, and you can see when I edit this joint, it's kind of off at an angle, and it thinks, oh, I need to be rigid or glued in place or welded in place. Well, we want it to be able to rotate to be able to get this hole to line up with the first hole. So instead of rigid, I'm going to change it to revolute. We get the little preview, and now when I say okay, we can actually see that that worked. Now I know it was kind of different, but the key thing there is you can actually have more than one joint on a particular component. Again, it kind of depends on what kind of joints you're doing, but in this case, the default was rigid and it was giving me some conflicts. So I went back and I just made it so we could rotate that part to fit exactly on that other component. So hopefully this tip will help you in the future. I thought this was kind of a good example to show this. I know we're going to talk about McMaster-Carr parts, but I just wanted to go ahead and position that in the correct location. Okay, so what we're going to do now is I want to show how this thing's going to get assembled. And you can kind of see we've got some bearings, we've got some bolts, and we've got some nylock nuts on here. And instead of modeling these myself or going out and finding where to download them, maybe off of like GrabCAD or something like that, we have built right into Fusion the ability to insert a McMaster-Carr component. So you'll notice I'm in the Insert menu right now. And in there is Insert McMaster-Carr. So I'm going to go ahead and click on that guy. And it brings up our McMaster-Carr window. And you can see all of the different categories. In fact, I'm going to make this a little bit larger. So I'm going to kind of stretch this over. So you can see screws and bolts, threaded rods, U-bolts, nuts and washers. I mean, there's pretty much anything you can think of in here. So for example, I know that I need to use a 608 2Z like skateboard bearing for this. So I'm going to just do a search for 608-2Z. And sure enough, as I'm typing that in, you can see it comes up with a whole bunch of different options here. Okay, so I'm just going to go ahead and hit enter. And what it does, and this is my favorite part, you're going to see us use this section over here quite a bit, but it shows all of the different kinds of bearings that McMaster-Carr has. Okay, and there's quite a few of them. So what I like to do is to filter down the design. So in my case, I want to use sealed bearings. So I'm going to go ahead and click on sealed, and now you'll notice it's kind of filtered those down. Okay. Then we can also see we have other options here. So for example, we have precision ball bearings, stainless steel ball bearings, etc. Okay. Now the thing you want to do is you'll notice, and it's kind of hard to see, but there's usually going to be a product number. And it's kind of highlighted in blue. So we can see this 5972. So I'm just going to go ahead and click on that link. And what this does is if you see this little CAD symbol, that means that McMaster-Carr has a CAD drawing or a 3D model of this particular product. So I'm going to go ahead and just click on that guy. And now I get a lot more information. What's the shaft diameter, the inner diameter, outer diameter, etc. So you can kind of see all of this information. But as I keep scrolling down, we're going to see the drawing for it. And then finally you'll see this little pull down. I'm going to scroll down a little bit more. And you can see that they have 3D models and 2D technical drawings. And all you have to do is pick one of these options. Now, I personally like to use 3D Step. So I'm going to click on 3D Step and say Save. Now, you'll notice how quickly it brought that into our session. This is an actual 3D model. If I zoom up on this, now I could have drawn this by hand, but it would have taken me some time. I'd have to research everything, etc. But here I'm able to just go to McMaster-Carr's webpage and bring it right in. Now it came in a kind of an odd orientation. It's like horizontal and it's not where I want it to go, but I'm just going to go ahead and say OK. Now I want this bearing to sit on this little bearing race right here. So I'm going to use the Assemble menu, and we're going to use the Joint command. Now, if you haven't seen my live stream that I did on parts and assemblies, I highly recommend that you watch that one. We'll link it in the description. I talk a lot about the difference between bodies and components, and one of the tips that I use myself is which one's component 1 and which one's component 2. Well, I've come up with a little saying that helps me. Which one do I want to move? And where do I want to move it to? And that's how I remember. So this is the one I want to move, and I want to move it to over here. So that's what I'm going to do. I'm going to kind of zoom up here, and I'm just going to pick, for example, this edge. It can be any of these edges. So I'm going to go ahead and click on that edge there. That's the one I want to move. And I want to move it to, for example, this edge here. And it's going to go ahead and move that bearing, and you'll see that it positioned it exactly where I wanted it. So it's axially lined up in the correct axis, and it's sitting on that particular little face. It's kind of hard to see through there. Now, if for any reason, and we might run into this, if for any reason it came in looking like this, where it positioned it in the right axis, but it's, you know, clashing through the part, you can flip the orientation using this little flip icon right here. Okay? So I just used McMaster-Carr to bring in that bearing, and then I've positioned it where I want it on that part. So the next thing I want to do is I'm going to go ahead and copy this because I want to put another bearing right inside of here. Now I could go into McMaster-Carr and do the search for it again, but I know that this is the correct bearing. In fact, I could even come in here and rename this. I'll just call it bearing. And let's just say move copy. And when I do move copy, one of the first things I want to do is to make sure I check create copy. Okay. And then I'm just going to go ahead and drag this out in space somewhere. I don't really care where. I'm just going to kind of get it out of the way. And I'll say, okay, I now have bearing 1 and bearing 2. Let's go ahead and create a joint. Put this in the correct location. So I'm going to say that edge there and this edge here. Now again, notice I'm accidentally hovering over that edge and it's catching that point, and I do not want that. I'm going to move down the edge a little bit until I get, you know, the actual edge, and you can see that little kind of like the smiley face kind of in the middle. That's what's called a joint origin, and so it's going to line up the center of the bearing with the center of that one there. Okay, so we can kind of see how it moved that bearing over, and it's now lined up axially. I'll say okay. Now here's another thing. I could make these revolute and actually have them spin around, but you need to think about, are you going to actually show that, or is this just more like positioning? I just want to get this part from point A to point B, and that's where it's going to be. I could make it revolute, but in this case, I'm just going to leave it rigid. I just want all of these things to move together. Now, the cool thing is, if I make them rigid, I can always come back and change them to revolute if I need to. We'll go ahead and say okay, and now I have that bearing there and that bearing there. Okay, so the next thing we want to do is somehow hold these bearings in place. So we're going to go out and we're going to search for a metric 8 by 60 bolt. Okay, so let's come over here. We'll go back into the insert command and say insert McMaster-Carr component. I like to make this a little bit bigger just so I can kind of see more what's going on. So I'm going to go ahead and instead of typing in or searching for it, I'm going to kind of go through this menu here. So I'm going to click on screws and bolts, and you can see all of the different options for the different kinds of screws and bolts. Well, in this case, I'm going to do a hex head. And again, this I think is so cool. I said I want a metric 8, so I'm going to kind of just start at the top and say I want metric, and it kind of filters everything out, and now it shows me all of my options just for the metric hex head screws. So let's pick on metric 8. And so now we're kind of filtering for metric 8. Maybe I want stainless steel. And I know that the length I want, so I can go ahead and drag this down a little bit, is in the 60. So I'm going to say 60. And then you can also see we have the option of fully threaded or partially threaded. So I'm going to go ahead and say partially threaded. And it's literally filtered me down to my one option here. Instead of going through a whole bunch of tables or whatever, it's showing me that here's a metric 8 stainless steel, 60 millimeter long, partially threaded hex head screw. So again, I see this little CAD symbol. I can go ahead and click on that guy. And just like before, it kind of shows a drawing, a little rendering of it. It remembers my last option, which was step. So I'm just going to go ahead and click on save. And it takes a moment to come in. And again, it kind of puts it up in space somewhere. Now, if you want to, you could, rotate it so it's more in the direction that you want or whatever. In fact, I'll go ahead and do that just for fun. And then maybe I could even kind of position it closer to where it needs to go. However, we're going to use the joint command to make sure it gets put in the exact correct location, but you can kind of drag it around if you want to. So I'm just going to go ahead and say OK, and there we are. So let's go ahead. I'm going to capture my position and create a joint. So I'm going to zoom up on this head right here, and you're going to see a couple options, okay? If I hover over this face, you'll see a lot of these little kind of, like I call them tick marks. So there's round ones for the ends of a line. There's little triangular ones for the middle of a line. So you can it's kind of hard to not move my mouse because it wants to snap to it. But you can kind of see the triangles in the middle. And then you'll see a little plus symbol right here in the very center of the shaft of the bolt. And that's the exact center of that axis, okay? So that's if I hover over this face. If I get near this edge, you'll see that it automatically snaps to the center of that edge. And I personally like to use this one because to me, it's confirmation that it's actually grabbing the center of that edge, and we also know that that edge is planar on that face. So it's basically grabbing the center of that and the center of that plane. So this is the one I want to move. And where do I want to move it to? Well, I want to move it to this bearing over here. So again, I'm going to kind of just hover over that edge and click, and it's going to move that bolt into the correct location. Again, I could hit play. You can kind of see it's showing that it's rigid in this case. And pretty much like I said before, I'm going to leave everything rigid for now. So we just positioned that screw where it needs to be. Okay. So the next thing I want to do is put one of those nylock nuts on the back. So again, I'll come into the Insert McMaster-Carr component. I'll stretch this out a little bit. And this time I'm going to click on the nut icon. And I want to do some kind of a lock nut. So I'm going to go ahead and click on lock nut. But again, notice all of the different options in here. You should hardly ever have to draw anything hardware related. I would definitely come out to McMaster-Carr first and see if it's in there. So I'm going to click on lock nuts, and again, I have some different types here. So I'm going to do this lock nut. I know I want a metric 8, so I'm going to filter through and say metric 8. I'm going to go ahead and keep it stainless steel. So let's do the stainless steel. And you can kind of see it kind of filters it out. It gives me a couple different options here. But I'm going to go ahead and just use this very first one. I'll click on this little link. I see the little CAD icon, so I can go ahead and click on that product detail. It shows me everything that I want to know about it, which is kind of nice. And I'll click on save. Now, last time I kind of moved it around. This time I'm just going to leave it. I'm just going to go ahead and say OK. And it's just out there in space. And we'll do the joint command again. So I'll say joint. I'm going to zoom up a little bit. Now here you'll notice, because this is kind of threaded, it kind of cuts the circle in half. Now it's still showing me the center of that circle, but in this case I'm going to go ahead and hover over this face, and you can see all of the options that it's giving me. So I can catch, to these midpoints if I want to. but I can also catch to this particular little plus symbol. Now, I covered this again in my parts and assemblies live stream that I did, which we'll link to. But as you're moving around, you'll see it's going to try and snap to all these other faces and edges, and it can get really confusing really quick. Okay? So here's a tip. You hover over what you want, and you want to control your selection. So on a PC, I'm just going to hold down my control key. And now when I move my mouse, you'll notice it's not catching any other edges or faces because I'm controlling my selection. As soon as I let go of control, you can see it's back to trying to snap to everything else. Okay? But if I hover over what I want, hold down control, I'm now controlling my selection. So I can very easily click on that little icon. And I'll come over here. And I'm going to zoom up again. Now here's another thing. You'll notice I could hover over this face and catch to that little center. I could hover over this edge and catch to the center. But I need to be really careful because if I start to move, I'm going to get a bunch of other things. So again, I really like the fact that I can hold down my control key to control my selection. So I'm going to go ahead and click that little icon, and it's going to go ahead and move the nut in place. I'll say OK. And we've now created basically this subassembly. Now, if I go ahead and try and move this bearing, you'll see that the whole thing moves because we basically attached it, made it rigid with this purple part. Okay, and that's going to come into play here in just a moment. I like to change the appearance, so let's go ahead and hit A for appearance. And let's make these aluminum bearings. I'm just going to drag aluminum onto the bearing. You can kind of see what that looks like. Maybe we want to do stainless steel because that's what we picked. So I'm going to say stainless. And then we could do maybe a polished stainless steel if you want to, or a satin. It's really up to you. But I went ahead and just added some appearance to that to make it look a little bit more realistic. In fact, you can kind of see the galvanized pipe that I'm using. Okay, now I need to do the exact same thing over here. Well, let's save some time. Instead of bringing everything back in again, we're going to reuse this. And to do that, I want to organize this basically into a subassembly. So you can see that we have this bearing, we have another bearing, and then I'm just going to rename this metric 8_60 bolt. So we kind of know what that is, and then we know that this is a metric 8 nut, let's just say. Again, I could have left the part numbers in there if I wanted to, but I like to rename these so I can kind of see what they look like, what they are. Okay, here's a neat little trick. We can see I'm at my top level assembly right now. I'm just going to right mouse click and say new component. And it's going to create a new component underneath that. And I can rename this. In fact, I'm going to call this bearing assembly. Let's just call it bearing assembly. And then I'm going to drag this bearing, the second bearing, the nut, and the bolt. I'm just going to drag these into that bearing assembly. And now you'll notice the icons changed a little bit, and that's showing that there's multiple components underneath this bearing assembly. Hopefully that makes sense. Okay, then I'm going to come back to my top level assembly. I'm going to activate that just by hitting that little radio button. And what I can do now is I'm going to just right click on bearing assembly, and I'm going to say move copy. Again, the first thing I want to do is click on create copy. And I'm kind of emphasizing that because if I start to move, it assumes you don't want to copy it and you just want to move it, and it basically grays this out. So I'm going to go ahead and say create a copy. And I'm just going to drag it to the right, some random distance. And I'll say OK. OK, now we'll see that we now have bearing 1 assembly and bearing 2 assembly. But if I grab on that bearing there, you'll notice that I'm able to move it away. And the reason for that is when we were putting these bearings in place, remember my little saying where I said, which is the one that you want to move and where do you want to move it to? And we were moving it to edges on this purple part. So over here, it doesn't know which edge. So these are all like individual. You can kind of see the nut and that particular bearing aren't moving with it. So here's another trick that I do. I just come in here and I'm going to say, I want to move all of these as a rigid group. So if one of them moves, I want all of them to move. And you'll notice it says constrain selected components. Do I want to continue? I'm just going to go ahead and say yes. And basically select all 4 of these components. And I'll say OK. Now if I move that bearing or the nut, they all move together. And if I were to position them using, like, for example, the joint command, which one do I want to move? Well, I'm going to go ahead and pick on, for example, this edge of this bearing. I'll come over here. I'll click on where do I want to move it to? I want to move it to this edge here. Now you'll see something interesting happen. I'm going to zoom out. You'll see that just the bearing has moved. And the reason for that is we're only dealing with 2 components at a time. Which one do you want to move? Where do you want to move it to? But as soon as I say OK, those other joints that know they have to be rigid all together as a group. Remember we did that rigid group? It knows that they have to stay together, so it's going to move all of them at the same time. So I know that kind of freaks some people out sometimes when they just grouped everything together and then they go to position it and only one part moves. As soon as you say OK, everything will update accordingly. Okay, so we've very quickly actually created these 2 little sub-assemblies for rolling on top of this pipe. Now we have kind of the same thing underneath. We actually have location for 3 bearings. But we're going to use shorter bolts because we don't have to go quite as far this time. So I'm going to go ahead and let's just expand open and pick one of these bearings. So I'm going to grab that bearing there and I'm going to say move copy. Go ahead and click on create copy and let's just move it down. Oops. Didn't mean to do that, sorry. Let me click on bearing, I'll say move copy. Grab the arrow, drag it down a little bit, and I'll just say OK. And you'll see that it's going to create its own little bearing right here. In fact, if I hover over it, you can kind of see it changing color on the screen a little bit. So because this is my active component, it put it underneath that particular component at that level. I'll go ahead and put it where I need it to go. So we'll say joint. I'll kind of zoom up here a little bit, making sure I grab that edge, and it's going to place that where it needs to go. Then the next thing I need to do is to, again, grab a bolt or a screw. So I'm going to come in here and say insert McMaster-Carr. I wish it remembered the overall size. I think it just goes to a default size. But I'm going to go ahead and click on the hex head screw, metric. We know we want a metric 8. But this time I want the length to be 30. And I want it to be fully threaded. So I'm going to say fully threaded. And now I can see all of the different options. So let's go ahead and just use maybe like a stainless steel hex head. And here it shows me a couple different options. I have coarse or fine, fully threaded. So I'm just going to go ahead, let's do a coarse thread. I'll click on that number, product detail, save. And it's going to go ahead and bring it into my session. Let's do the joint command again. Now again, because there's like edges and threads and stuff like that, I'm going to hover over this face, hold down my control key to control my selection. I'm going to grab that little plus symbol you see right here in the middle. I'm going to move away from it so you can kind of see it. That shows the center of an axis. So I'm going to grab that guy and position it where I want. So I'm gonna stay zoomed out so you can actually kind of watch it move. So I'm gonna click on that edge there, and you can see how it rotates and brings it into place. I'll say OK. Now actually here's another cool little trick. You'll notice that there's options here and stuff like that. So I could actually grab this and actually rotate the whole bolt if I need to. So it kind of comes in at a default angle, like 0 or 90 or whatever. I could also offset it a very particular distance. Once it's located in place, I could offset it if I needed to. But in this case, obviously, we're not going to. I'll say OK. And I now have the bearing and the screw in place. And I know that that's a metric 8, so I could go ahead and let's use one of the nuts again. So I'm going to right click on it, move copy, say create copy, and I'm just going to drag it kind of out away from everything like so. And there we can see it. We'll use the joint command again. A lot of this is kind of repetitive, but you'll see how quickly we can create what this is going to look like. So again, I'm just going to hover over, grab that center point, and it's going to put the nut right where we need it to be. And I'll say OK. And we basically have that little subassembly. And I want to, put it in 2 more locations. So just like before, I could create another subassembly. So I'm just going to say new component. And I'll call this bearing assembly short or something like that maybe. Okay. And I'll just grab these 3 parts. Make sure I grab those guys, drag it down, and I now have this bearing assembly short. Now, if I were to, I'm going to purposely make a mistake here. I'm going to go ahead and say move copy. And I'm going to turn on create copy, and you'll notice it's going to sit for a little bit, and it'll come up and it says the selection cannot be copied because it contains the active component. So what does that mean? Well, you'll notice basically this is my active component, and I'm trying to copy that. So that's what that warning means. So what I need to do is go up a level. So I need to go, for example, up to my top level here and activate that guy. Now when I come in here and I say move copy, create copy, you'll notice I don't get that warning message. Okay? You're basically, you can kind of think of it almost like a parent or child relationship. A child can't copy a child. You have to have the parent's permission to do that, right? So the parent is going to be the active component. Okay. Okay, so I got that where I want it to be. I'll say OK. And again, I might try moving this around, and sure enough, I can see that those are not connected. So let's go ahead and just do a quick rigid group. I'll select all 3 of those. And I might get the message, saying that it constrains selected components, and that's probably because of this include child components. I'm just going to leave that alone for now. I'm going to go ahead and say yes. I'll say OK. And now they're all grouped together. We'll do the joint command. Now I'm gonna basically put the face of this bolt on the face of this purple part here. So I'm gonna kind of zoom up, control my selection so I can grab that guy there. Control my selection and grab that guy there. And again, you'll notice it's just moving one of those parts, but as soon as I say okay, the other ones have to update accordingly. And then we'll do that one more time. I'm just gonna go ahead, my top level assembly is active, so I should be able to come in here and say move copy. If I knew the distance, I could go from point to point. In fact, this is kind of cool. I'm going to go ahead and turn off that bearing assembly. And in here, I'm going to say create copy. I have the option to translate, rotate, and also go from point to point. So I could say, what's my origin point? I'm going to grab that guy. What's my destination or my target point? I'm going to grab that guy. We'll say okay. Now they're both turned off, so let me turn them back on. And instead of having to move them out into space and then use the joint command, I was able to move them over. However, we didn't use the joint command, right? So this doesn't know that it's supposed to stay rigid with the purple part. So I personally like to use the joint command, okay? So I'm going to undo back. We're back here. I'll come in and say move copy. And I'm just going to, drag this guy out a little bit, like so. If I were to test this, you can see that it's a rigid group. So I know that that's correct. And then finally I can come in and say, okay, I want to create a joint that goes from, let me rotate a little bit more so you can kind of see it, the center of the screw to the center of this location. And I'll say, okay. So, quick review there. I showed how you could create a copy and then just move it to a location. And then I said that's not the best method. I mean, if you don't care about joints or having things move together, that would work. But in this case, we want that whole assembly to move together. So I want to make sure I'm using, the joints command. So that's why we did that section twice. Okay, I've got that whole area. Now, let's say we want to simulate how this is going to move. So I'm going to go ahead and grab this, and we can kind of see how I'm able to kind of just freely move that around. Well, I obviously want to keep this pipe in the correct location, and I want it to slide in the correct orientation. So, because this pipe is basically clamped into place, I'm just going to come in here and say rigid group. I'll say this pipe and this purple part have to move together. So now if I grab that purple part, you'll see that that pipe moves with it. It's a really quick way of doing that. Instead of, having to do a joint and say, the edge of this is touching the edge of this or whatever, if it's already in the correct location and they move together, just make them a rigid group. Okay, the next thing I want to do is to make it slide back and forth. So I'm going to come in here and I'm going to use a cool command called Asbuilt Joint. Because these parts are already where they need to be, I can use what's called an as-built joint. So what's the component? Well, I'm going to say this part here, and I want it to slide along the pipe, so I'm going to go ahead and click on the pipe also. Now it's asking for a position, and it's kind of hard to see, but you'll see as I move my mouse, I have this little icon. In fact, I'll kind of hover right here. You can kind of see that little icon is the slider icon. So I have the option to specify an endpoint, a midpoint, or an endpoint. Well, in this case, I'm just going to grab this midpoint, and that's going to basically be our 0, 0. So I'm going to go ahead and click there, We can see how it's basically going to slide to the left and to the right, and it returns to that midpoint. Again, I cover this more in depth in the Parts and Assemblies live stream. Okay, now let's see what happens when I grab my purple part. Well, everything moves. And that's because we haven't grounded anything. Fusion doesn't know which part is stationary, which part is held in place. And in this case, we want to simulate that this purple assembly and this pipe are going to slide back and forth on this other pipe, which if I click on it, I can see is called Tube 2. So I'm going to right mouse click on that and ground it. And you'll see a little pin icon appear on that little cube right next to my cursor right there. And it basically means I can no longer move this pipe. If I try and click and drag on it, it's physically grounded in place. But if I were to grab this guy, I can now slide back and forth. We can kind of simulate how that would work and how that would look. I'll go ahead and revert it back. So I think that's kind of cool. We can actually simulate how this thing's going to look and how it's going to work. And again, this is just a sub-assembly. You know, if I had it on the other side, it would move also, etc. Okay, so the last thing we're going to do with this assembly is I want to bring in a stepper motor. Now, I could go out to like GrabCAD, I could go out to maybe a manufacturer's site and look for a stepper motor, but believe it or not, McMaster-Carr actually has them also. So I'm going to come in here and say, Insert McMaster-Carr component. And I'm just going to start to type in stepper in the search window. And sure enough, you can see there's stepper motors. So I'm going to go ahead and click on stepper motors. I want to do a NEMA 17. So I'm going to filter out to the NEMA 17s. I'll make this a little bit larger so we can kind of see what's going on here. And here you can see all of the different options. We got motors, drivers, controllers, with integrated drivers and controllers. But in this case, we're going to just do, I'll go ahead and do the largest one here. So you can kind of see it's actually broken down. There's multiple links. This one is for the motor. This one is for the driver. And this one is for the controller. So I want to make sure I'm grabbing the right one. So I'm going to grab the motor. So I'm going to click on that one. Product detail. And again, it gives me all of the information about this particular stepper motor. And, you know, dimensions, etc. I'm going to just say save. And we'll bring it in. So there it is. So I'm going to just leave it where it is for now. I'll say OK. And as we rotate, you'll notice that there's a plug-in at the top. Or actually, I want to make this be the top of the stepper motor. Now, I already have some holes here. Hopefully, they'll line up. So I'm going to come in here and say, let's create a joint. And I'm just going to pick maybe this lower left corner. So I'm going to hold down my control key, grab the center of that hole. And then I want to make sure I grab the same circle over here. So this lower left one. So I'll click on that and we'll see that it's going to go ahead and position our stepper motor in place, and our plug-in is at the top. And sure enough, it looks like the holes are lined up. We can verify that using a section analysis, but I'm going to go ahead and say OK. And we just brought in a stepper motor. I didn't have to model it. I mean, you can see it's even almost like a sub-assembly. It's got screws. In fact, let's take a look at this. Let's expand this open. So it actually has two separate bodies. So you can kind of see that the shaft is separate from the body, if need be. Okay, well now we need to somehow mount this in place. And this time I want to use some washers. So let's go ahead and insert and search for some washers. So I'll click on washers and see all of the different options. We'll click on flat, metric. Now, I'm not sure what size holes these are, so let me just go ahead and inspect one of these. So it's a diameter of 3.2. So we can guess that it's going to be a metric 3. So I'll do that again. I'll come in here and say, let me drag this down, washers, flat, metric 3. And again, I still have more options here. Inner diameter, outer diameter, you know, what material is it made out of. I'm just going to pick the general purpose one. And, you know, the stainless steel. So let's just do, for example, this guy here. Product detail. And save. Okay. All I have to do again is use the joint command. So I'm just going to get near one of those edges. And near that edge there. And here's the example I was talking about earlier. I was hoping this was going to happen. So it put it in the correct location, but it's sunk inside the part. So here's where I just have to hit that little flip icon to flip the orientation. I'll say OK. And I want to put this in these 4 other locations. Now, I could create a sub-assembly like I did before, but I'm going to show another method. And in this case, we're actually going to create a pattern. So let's go ahead and rename this guy. I'm just going to call this M3 washer, so I know what it is. I'm going to rename this guy stepper, NEMA 17 or something like that. Again, I like to kind of rename my parts and organize my browser here so things make more sense. Okay. So what I'm going to do now is use the create pattern, and even though, this is kind of funny, even though it looks like a rectangular pattern, I'm going to do a circular pattern. And the reason for this is because it's actually easier. I only have to specify one direction, or actually an axis, where a rectangular pattern you have to say go a certain distance to the left, go a certain distance down. Well, I'm going to say circular pattern. We'll click on the washer as our component. What's the axis? I'll go ahead and click on one of those circular edges there, and you can see that it's going to pattern those washers. But right now it's doing a quantity of 3. But as soon as I go to a quantity of 4, you'll see that it actually lines those up. I mean, I could keep going, right? But 4 makes sense. So I'm going to go ahead and say OK. And we just patterned those washers around. Okay, so the next thing I want to do is we're going to put a metric 3 hex head screw through here. But I need to know the correct depth. So here's a neat little tip. In fact, I'm going to go ahead and let's do a section analysis. I'm going to slice down through my design, and we can see that, you know, how deep this screw hole goes. Okay, so what I'm going to do is measure. So I'm going to just click on my measure, and I want to know how deep it is from the front of this washer. So I'm going to click on that front face of the washer, and then I'm just going to click on the back face there, and it's telling me that the distance is about 8.41. So I know I could probably use a metric 8. I'm sorry, a length of 8 millimeters for the length of the screw. Okay, so let's go ahead and remember 8. So I'll come in here and say insert a McMaster-Carr. I'm going to do the screws and bolts. This time I'm going to use a socket head cap screw, just to be different. Metric, we know it's a metric 3, and then we know our length is around 8. So I have the option of 6, 8, or 10. And these are all purchasable parts, so it's only going to show me the results that you can physically actually do. So I'm going to pick the length of 8. Again, I have lots of options here. I'm going to go ahead and just do this. Let's just do the stainless steel in this case. I'll move this over a little bit so we can kind of see more options. So it's showing me fully threaded, fine, or coarse. In this case, I'm going to do the fine because the stepper motor has fine threads. So I'll go ahead and pick on that guy. Save it. It's going to bring it into my session, and then all I have to do is position it into place. So let's just go ahead and say OK. I'll create the joint command again, making sure I grab, the edge, this outer edge, making sure I'm not grabbing like this point right here. I want to make sure I grab that outer edge, and it's going to bring my screw in there, but again, it's in the wrong orientation, so all I have to do is hit flip. And because we're kind of in this component, we can actually see the ghosted out. Let me kind of rotate here a little bit. You can see that sure enough, our screw goes in pretty substantially, but it does not bottom out. So that's why I like using that little measure trick to make sure I'm grabbing the right screw. And then I'll do the exact same thing again. Let's just do a circular pattern. What's the component? The screw. What's the axis? I'll click that same edge. We'll do 4 of them, and I'll say OK. However, now I have quite a few washers and screws and stuff like that out here, and I want to organize this a little bit better. So I'm just going to right-click at the top and say New Component. And let's just call this, stepper assembly or something like that. Okay, so I'm going to go ahead and grab the stepper and all of these other parts, the washers and the screws. I'm just going to drag those down into my stepper assembly. And you can see, much simpler now. You can kind of see how easily this is organized, but if I expand open my stepper assembly, here is my stepper and all of my hardware. And what's neat about this is you can kind of see, for example, I could turn that whole sub-assembly on or off if I wanted to. In fact, let's go ahead and do this. I'm going to activate the top level assembly, and you'll see the power behind this. I can turn that stepper assembly on or off. Same thing with my bearings assemblies. I can turn all of these guys on or off very, very quickly instead of having to do individual bodies or individual components. So I highly recommend that you organize as easily as possible. In fact, if you wanted to, you could even come in here and say New Component and say, all bearings or something like that, assembly. And I could put these bearing assemblies inside this guy, like so. And if I want to, I can now turn off all of my bearings and the bolts and the screws all in one click. Okay, so hopefully you saw the power of using the McMaster-Carr under the insert menu, where we didn't have to model anything. I didn't have to model a stepper motor. I didn't have to model bearings. I didn't have to download nuts and bolts or anything like that. It's all out in this McMaster-Carr pull down. So hopefully you saw the benefit of that. Hope to see you on a future live stream. Make sure you subscribe. Thumbs up, thumbs down. Leave comments on what you'd like to see on future live streams, and hope you have a wonderful rest of your day. Thank you.